The objective for this video is to learn how to find the critical value for a chi-square goodness of fit test. The voter registrations for a certain city showed that 40% of its registered voters are registered as Democrat, 45% as Republican, and 15% as Independent. A poll of 200 citizens showed that 72 plan to vote for a Democratic candidate, 82 plan to vote for the Republican candidate, and 46 plan to vote for the Independent candidate. Can it be concluded at the 0.05 level of significance that this particular election will vary from the registration proportions? If the 200 citizens in the entire poll vote consistently with their party registrations, then we would expect that 40% of that 200, or 80, would vote for the Democratic candidate. Likewise, we would expect 45% of that 200, or 90, to vote for the Republican candidate. And we would expect that 15% of 200, or 30, would vote for the Independent candidate. The expected values that we just calculated and the observed values obtained from the survey are shown in the table. Step 1 is to form the hypotheses. If there is no variation in this particular election from the distribution of party registrations, then we would expect the proportion of those who vote for the Democratic candidate to be 0.40, the proportion who vote for the Republican candidate would be 0.45, and the proportion who vote for the Independent candidate would be 0.15. The alternative hypothesis would be that the distribution is not the same as stated in the null hypothesis. Step 2 is to find the critical value. We will use the chi-square distribution table to find the critical value. The number of degrees of freedom will be one less than the number of categories. We have 3 categories, so the number of degrees of freedom is 2. With alpha equal to 0.05, we will find where the row with 2 degrees of freedom intersects with the column alpha equal to 0.05. So our critical value is 5.991. In this video, we learned how to find the critical value for a chi-square goodness of fit test.